Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to start Group 17 elements. Last class I have discussed sulfuric acid and finished Group 16 elements. Now I am going to discuss Group 17 elements under P block elements. Fluorine, chlorine, bromine, iodine and astatine are members of group 17. These are collectively known as halogens. What is the meaning of halogens? Halo, it is a Greek word, halo, means salt, and genes, Genes, genes means born, that is salt producer. Salt producers. Halogens means salt producers. The halogens are highly reactive non-metallic elements like group 1 and group 2. The elements of group 17 show great similarity amongst themselves. The elements of group 17 show great similarity amongst themselves. That much similarity is not found in the elements of other groups of the periodic table. Also, there is a regular gradation in their physical and chemical properties. Astatine is a radioactive element. Question is asked. Astatine is a radioactive element. Always you remember. Now I am going to discuss occurrence. Fluorine and chlorine are fairly abundant, while bromine and iodine less. Fluorine is present mainly as insoluble fluoride. Fluorine is present mainly as insoluble fluorides, as for example, as fluorspar. Fluorspar means calcium fluoride, CaF2, cryolite, Na3AlF6, and fluoroapatite means Ca3PO4 whole 2, CaF2. Fluoroapatite means 3Ca3PO4 whole 2, CaF2, and a small quantities of fluorine are present in soil, river water plants, and bones and teeth of animals. Sea water contains chlorides, bromide, and iodide of sodium, potassium, magnesium, and calcium. Again I am telling you, sea water, small quantities of fluorine I am talking about. Sea water contains chloride, bromide, halogen I am talking about. Sea water contains chloride, bromide, and iodide of sodium, potassium, magnesium, and calcium, but is mainly sodium chloride solution, that is a 2.5% by mass. Okay. Sea water contains chloride, bromide, and iodides of sodium, potassium, magnesium, and calcium, but is mainly sodium chloride solution. It is found sodium chloride solution 2.5% by mass. The deposit of dried Upsc contain these compounds, that is the sodium chloride and carnallite. Carnallite means KCl, MgCl2, 6H2O. Certain forms of marine life contain iodine in their systems. Marine life contains iodine. This iodine is found in less quantity. Certain forms of marine life contain iodine in their systems. Various seaweeds, for example, contain up to 0.5% of iodine, and Chile saltpeter contains up to 0.2% sodium iodate. Now I will discuss about atomic and physical properties of halogen along with the electronic configuration. Fluorine, its atomic number is 9. Chlorine, atomic number is 17. Bromine 35. Iodine 53. Statine 85. And this atomic mass means in gram per mole. Then fluorine is 19. Atomic mass is 19 gram per mole. Chlorine 35.45 and bromine 79.90. Iodine 126.90. Statine 210. This I have told about the atomic mass in gram per mole. Now electronic configuration. Actually, in terms of helium, neon, argon, krypton, xenon, I will tell you, means complete octet I will write, and after that I will tell electronic configuration. Then fluorine, helium, suppose helium octet is completed, means 2 electron is filled. Then now 2s square 2p5. Last orbit total 7 electrons are there. 2s square 2p5, and outside helium is there. Completed helium structure, electronic configuration. Second, chlorine, its electronic configuration is neon is completed. After that 3s square 3p5. Here also total 7 is there. 3s square and 3p5. Like that way, bromine, argon is completed. After that 3d10 4s square 4p5. Here also last orbit 7 electrons have. In all this electronic configuration of halogen, last orbit has 7 electrons. Now come to the iodine. Then now krypton, after the krypton it is a 4d10. Krypton is suppose filled. Then 4d10 5s square 5p5. And xenon, for statine, xenon is completed, and after that 4f14 5d10 6 square 6p5. Actually this atomic number is 85. then it will arrange like that electronic configuration. Xenon will be filled, and after that 4F14. F has maximum 14 capacity. 14 electron can be accommodated. 5D10, and then again 6 square 6P5. Means in every electronic configuration of every atom, fluorine, chlorine, bromine, iodine, statine, last group is filled. This is 7, you can say, only 7, not completely filled. 1 is lagging behind. Only 7 everywhere. Last 7 electrons. Last orbit 7 only in every elements of halogen. Now covalent radius in term of picometer. Covalent radius. Then fluorine is 64 picometer. Chlorine is fluorine F 64. Chlorine 99 means more. And bromine furthermore 114. And iodine furthermore 133. And statine is radioactive elements. Okay, radioactive elements. And its covalent radius is not given. Ionic radius. Actually covalent radius you know. And now ionic radius I am talking about. Means ionic radius means X minus. Means after taking the electron, one electron, what is its radius? That is called ionic radius. After taking one electron, 7 is there, one electron taken. Then after taking one electron, what is the ionic radius? Ion it formed. Then its radius. Covalent radius, you know, it is a sharing. It is due to the sharing. Then ionic radius in picometer for fluorine is 133. It is more than covalent radius of fluorine. Chlorine is 184, more than covalent radius. It is 99, but now ionic radius is 184. Always you remember, ionic radius is greater than covalent radius. Bromine is again further more than this covalent radius. Covalent radius is 114, but it is ionic radius is 196. And iodine, again covalent radius is 133, but it is 220. Statine is not known. It is radioactive element. Now ionization energy or ionization enthalpy in kilojoule per mole. I am telling you. Ionization enthalpy or ionization energy, I am talking about in terms of kilojoule per mole. Then this for fluorine, it is 1680. Chlorine less 1256. Bromine slightly less 1142. And iodine is further less 1008. Okay, and statine is not known. Okay, it is radioactive element. Now electron gain enthalpy, also called electron affinity. Electron gain enthalpy, it is also in term of kilojoule per mole. Then fluorine is minus 333 minus. And for chlorine, it is further less, because in the term of minus 349, and bromine minus 325. Means now it is these things minus 3T5. Then in comparison to the other two, means fluorine and chlorine, it is a high, means minus 325. Minus 325. Fluorine was minus 333, correct? And bromine is minus 325. And iodine is again more, means minus 296. Minus value is decreasing, correct? And again statin is not known, that is for statin electron gain enthalpy is not known because it is this radioactive element. Electronegativity is important, you should know. On Paul scale, its value I am telling you. Pauling scale. On Pauling scale, electronegativity means electron attracting capacity. Then fluorine is highest, 4. Highest means 4. And next is chlorine, 3.2. Third is bromine, 3.0. Fourth is 2.7. And fifth, statin, its value is 2.2. List. Question is asked, about the electronegativity. Here you should know, fluorine has the highest electronegativity value in whole periodic table. Second is oxygen. Third is nitrogen. And then fourth is the chlorine, fifth is the bromine, sixth is the iodine, and seventh is the statin. Then question is asked, then I am telling you fluorine first, highest, second oxygen, third nitrogen. After that fluorine, chlorine, bromine, this chlorine, bromine, iodine. Its value is after nitrogen. After nitrogen, chlorine, then bromine, then iodine, then statin. Now I am talking about hydration energy. Then hydration energy means in term of kilojoule per mole, means how much water molecules it can absorb, and that time how much energy it will release. Hydration energy. Hydration means always capacity of absorbing water molecules. At that time it will release energy. Then fluorine is highest, 515. Second is chlorine, 381. Third is bromine, 347. And fourth is iodine, 305. Fifth is statin is not known. Now other physical properties I am telling you. Melting point. Melting point of fluorine is 54.4 Kelvin. In term of Kelvin, 54.4 Kelvin. So less. And chlorine gas I am talking about. Chlorine gas means Cl2, 172. Bromine gas, 265.8. Iodine gas is highest, 386.6. Again I am telling you, F2 means fluorine melting point, fluorine gas, that is a very less, 54.4. Cl2, 172.0. 172. Bromine, 265, more than chlorine. And iodine, 386.6. Statin is not known. Boiling point of fluorine is 84.9. Chlorine is 239.9 more, and bromine is furthermore 332.5, and iodine is 458.2. Statin is not known. Density means gram per cc or per ml, both are same. Means mass of 1 ml, mass of 1 ml in term of gram per ml, that is the density. Then it is heaviness also you can tell. Then fluorine is 143, less than chlorine. Chlorine is 199 and bromine is 228, more, furthermore. And highest is iodine. Means among 4, iodine is heavier per ml. Per ml or per cc, what is the mass? Then for fluorine gas only 143. Chlorine 199, heavier than fluorine. And bromine 192, not 192, 228, more than chlorine. And iodine is furthermore 266. Now bond dissociation enthalpy. Bond means F2 bond is there, then F bond, when bond will break, how much energy it will release. Okay, that is called bond dissociation energy or enthalpy. Then bond dissociation enthalpy for F2. In F2, 2F is there, bond is there, FF. Then if it will break, it will release 158.8 kilojoule per mole. Chlorine 242.6 kilojoule per mole. Bromine 192.8 kilojoule per mole. And iodine 151.1 kilojoule per mole. Means it is decreasing. This is the bond dissociation enthalpy for fluorine, means FF bond. Chlorine means Cl bond. Bromine Br bond. Iodine I bond. Then in breaking this bond, this amount of energy is required. Means for fluorine 158.8 and chlorine 242.6, bromine 192.8 and iodine 151.1. Okay, and this volt means electrode potential I am talking about, electrode potential. Then for fluorine F2 it is a 2.87 volt. Okay, and for this chlorine 1.36. Actually here electrode potential E standard value I am telling you in terms of volt. In terms of volt, electrode potential in terms of volt. Then for fluorine is 2.87. For chlorine it is 1.36 volt. Bromine is 1.09 volt. And least is iodine 0.54 electrode potential. Okay, means electrode potential means if it will tendency to lose the electron or tendency to gain the electron. That is that time what is the potential? That potential I have told you, that is called standard electrode potential. This I have discussed about the physical properties, atomic and physical properties. Now a little more I will tell about the this atomic and physical properties of halogen. Electronic configuration already I discussed. All these elements have 7 electrons in their outermost shell, and its formula is ns square np5 in general, which is one electron short of the next noble gases. Okay, noble gases you are writing in the beginning, then it is less, means ns square np5, then total 7, ns square means 2, np5 5, then 2 plus 5 7, 1 is lagging behind. That's why we are telling which is one electron short of the next noble gas. Atomic and ionic radii, again I am giving focus on that. The halogens have the smallest atomic radii. Halogens have the smallest atomic radii in their respective periods. Due to maximum effective nuclear charge. Why it is the smallest? The halogens have the smallest atomic radii in their respective periods. Due to maximum effective nuclear charge, they are attracting, nucleus will attract the electron. That's why this will be a smallest atomic radii due to maximum effective nuclear charge. Always you remember, question is asked. The atomic radius of fluorine, like the other elements of second period, is extremely small, very small size, fluorine size. Okay, the atomic radius of fluorine, like the other elements of second period, is extremely small. Atomic and ionic radii increases from fluorine to iodine due to increasing number of quantum cell. Okay, because number of cell is increasing, new cell is opening, and in case of this other elements, always new cell will open. That's why this is in radii is increasing as you will go down in the group. Ionization enthalpy. Now I am telling you little more. They have little tendency to lose electron. First important point. Ionization means, you are talking about the ionization means losing of electron, loss of electron. That way you can take it. Then these halogens have little tendency to lose electron. Actually they are electronegative. They have tendency to accept. They don't want to lose. That's why they have little tendency to lose electron. Thus they have very high ionization enthalpy because they don't want to lose. If anyhow you want to remove the electron, then more energy you have to supply. Thus they have very high ionization enthalpy. Due to increase in atomic size, ionization enthalpy decreases down the group because size is increasing, hence little easily it can be removed. Then ionization energy decreases. Okay, ionization enthalpy decreases down the group. Now come to the electron gain enthalpy. It is also known as electron affinity. Halogens have maximum negative electron gain enthalpy. Okay, electron gain enthalpy always will be negative. Electron affinity will be negative. Halogens have maximum negative electron gain enthalpy in the corresponding periods. This is due to the fact that the atoms of these elements have only one electron less than the stable noble gas configuration. Electron gain enthalpy of the elements of the group becomes less negative down the group. In the beginning it will be more, but down it will be less. As you will go down it will be less. Electron gain enthalpy of elements of the group becomes less negative down the group. However, the negative electron gain enthalpy of fluorine is less than that of chlorine. It is due to a small size of fluorine atom. As a result, there are a strong interelectronic repulsion because fluorine size is small. Hence, whatever electrons are there, among them, repulsion will be there. Okay, there are a strong interelectronic repulsion in the relatively small 2p orbitals of fluorine, and thus the incoming electron does not experience much attraction, because then already their repulsion is there. If other electron will come, then what will happen? The incoming electron does not experience much attraction because their already repulsion is there. Okay, that's why I have told you that their value will be negative. Halogens I am talking, the negative electron gain enthalpy of these things, fluorine in halogen, particularly in fluorine, is less than that of chlorine, because chlorine is bigger than fluorine is smaller than chlorine, or you can tell chlorine is bigger than fluorine. Then in chlorine electrons are there but size is big, then their repulsion will be less, but fluorine is the smallest, then their repulsion will be more. As we will go down, then size will increase, hence repulsion among electrons will be less. Okay, then now I think you have understood negative electron gain enthalpy, and this I want to tell you now about the electronegativity a little. They have very high electronegativity, all halogens. The electronegativity decreases down the group. Fluorine is the most electronegative element in the periodic table. Okay. Now one question is asked. I want to clear that point. What question is asked? I am telling you. Halogens have maximum negative electron gain enthalpy in the respective period of the periodic table. Why? Halogens have maximum negative electron gain enthalpy in the respective periods of the periodic table. Why? How I am giving explanation. Halogens have the smallest size in their respective periods and therefore high effective nuclear charge. As a consequence, they readily accept one electron to acquire noble gas electronic configuration. Okay, that's it. You are comparing with other. Okay, with other respective periods of periodic table, which is close to the halogens. Then halogens have the smallest size in their respective periods and therefore high effective nuclear charge. As a consequence, they readily accept one electron to acquire noble gas electronic configuration. Effective charge is more. Okay, this because of a small size. Now other physical properties, I want to focus more on physical properties. Actually I have given data in the beginning. Now physical properties I am telling you. Okay, halogens display a smooth variation in their physical properties. Fluorine and chlorine are gases. Okay, fluorine and chlorine are gases. Bromine is liquid. Sometimes question is asked. Then you remember, fluorine and chlorine are gases. Bromine is a liquid and iodine is a solid, blue solid. Their melting and boiling points steadily increases with atomic number. All halogens are colored. Why it is colored? All halogens are colored. This is due to absorption of radiation in visible regions. Okay, question is asked, why all halogens are colored? Then this is due to absorption of radiation in visible regions, okay, which results in the excitation of outer electrons to higher energy level. By absorbing different quanta of radiation, they display different color. For example, fluorine has yellow, chlorine greenish yellow. Remember, fluorine has yellow color, chlorine greenish yellow, chlorine gas. Bromine means Br2 red, and I2, which is solid, it is a violet color. Fluorine and chlorine react with water. Okay, fluorine and chlorine react with water. Bromine and iodine are only sparingly soluble in water, but are soluble in various organic solvents such as chloroform, carbon tetrachloride, carbon disulfide, and hydrocarbons to give colored solution. I am telling you, the important question is asked. Okay, here you listen. Fluorine and chlorine react with water. Bromine and iodine are only sparingly soluble in water. They will not dissolve more. But where they will dissolve? Then they are soluble in various organic solvents such as chloroform. Second, carbon tetrachloride CCl4. Third, carbon disulfide. And fourth, hydrocarbons. And they will give colored solution. One curious anomaly we notice here, but this in what I discussed in data, that is the smaller enthalpy of dissolution of fluorine compared to that of chlorine, whereas X means halogen, X is halogen gas. XS bond dissociation enthalpies from chlorine onwards so expected trend that is, for example, that bond dissociation energy I am talking about, Cl is more than Br means Cl bond dissociation energy is more than Br, and Br is more than II. Okay, why like this? Then a reason for this anomaly is relatively large. This region I am talking, a reason for this anomaly is the relatively large electron repulsion among the lone pair in F2 molecules, where they are much closer to each other than in case of Cl2. In fluorine, lone pair of electrons are very closer, but in other it is little far. That's why Cl is greater than Br, and this Br is greater than II. Means chlorine is greater than bromine. Bond energy in chlorine, this is greater than Cl2 is greater than Br2 is greater than I2. Means Cl bond is greater than Br bond. Br bond is greater than II bond. Okay, and already explanation I told you what is the reason. The reason for this anomaly is the relatively large electron-electron repulsion among lone pairs in F2. In F2, more repulsion is there in comparison to the other molecules, particularly chlorine. Okay. One question is asked that I am telling you. After that, I will explain it. Question is that although electron gain enthalpy of fluorine is less, is less negative as compared to chlorine. Fluorine is a stronger oxidizing agent than chlorine. Why? This question is asked. Again I am reading. Although electron gain enthalpy of fluorine is less negative as compared to chlorine. Again I am reading. Although electron gain enthalpy of fluorine is less negative as compared to chlorine. Fluorine is a stronger oxidizing agent than chlorine. Why? Then there are two reasons for this. First, it is due to first low enthalpy dissociation of FF bond. First reason I am telling you, low enthalpy of dissociation of FF bond. And second reason, that is the high hydration enthalpy of fluoride ion. Okay, these are the reasons for this. Why you can say fluorine gas is less negative as compared to chlorine, and fluorine is a simple way why fluorine is a stronger oxidizing agent than chlorine. Okay, this explanation why fluorine is a stronger oxidizing agent than chlorine. Then it has two reasons. First, low enthalpy of dissociation of FF bond, and second, high hydration energy of fluoride ion. Now, chemical properties I will discuss. Okay. Oxidation state, today I will discuss only oxidation state. Oxidation states and trends in chemical reactivity. Now I am going to discuss oxidation states and trend in chemical reactivity. All the halogens exhibit -1 oxidation state, all. However, chlorine, bromine and iodine exhibit +1, +3, +6 and +7. Okay, these are important things. All the halogens exhibit -1 oxidation state. All the halogens. However, chlorine, bromine and iodine exhibit +1, +3, +5, +7 oxidation state. This also means along with the -1, this +1, +3, +5 and +7 also shows. Okay, means except fluorine only -1. All the halogens exhibit -1 oxidation state, but chlorine, bromine and iodine, these three exhibit both -1 and +1, +3, +5, +7. Okay. Now, why this happens, I am telling you. Halogen atom, that you have to see the electronic configuration. Only then you will understand. Then halogen atom, here you have to understand halogen atoms in ground state. Okay, halogen atoms in ground state and then excited state. You have to compare excited normal state, that is also called ground state, and then you have to consider in excited state. Then there also it will be first excited state, second excited state, and third excited state. 3 excited state you have to consider. Then halogen atoms I am talking about other than fluorine. Okay, other than fluorine means all that is the this bromine, as for example bromine, chlorine, this chlorine, bromine, iodine. I am talking about that. Then here you will see in general I am talking about fluorine, chlorine, bromine, iodine. Then NS, in NS 2 electrons are there in any elements, halogens, except fluorine. Okay, I am not talking about fluorine. Then in NS 2 electron is filled, and in NP 5 electrons are there. Then 5 electrons, then P has the three different type of orbitals are there, px, py, pz. Then 5 electrons are in the you can say 3 orbitals, px, py, pz. Then in px 2 electrons are there, in py 2 electrons are there, and pz only 1 electrons are there. Correct? Then now all 7 electrons are adjusted. NS 2 electrons and NP 5. Then 2 PX 2, PY 2, and PZ 1. 5 are there, and d orbitals are vacant. D orbitals are means ND are vacant. Then now here one unpaired electrons, that is in 5 electrons are there in p orbitals, then 2 are there, px2, py2, and pz is 1. Then due to this one unpaired electron accounts for -1 or +1 oxidation state, because 1 is there. Then it can take 1 electron. It can take 1 electron also. Then it will become 2. Last will be also each will be px, py, pz will be 2. If it will accept 1 electron, then it will show -1. And if 1 electron will go, then it will show +1. Hence -1 and +1 oxidation state both are possible. Now you can say, just to consider excited state, first excited state. Then what will happen? D orbitals are vacant, ND orbitals are vacant. Then now what will happen? That in p orbital, 2 orbitals having two electrons, and third was having 1 electron. Then now in first excited state, that this 1 electron after the excitation from the px, leave it, py 2 electron was there, then it will excite, means after getting energy it will excite, and it will go to the d orbitals. Then now 3 orbitals have single electron. Okay, already 1 was unpaired. Now after the excitation 1 went to the D. Then now in py 1 remained, and already in z 1 was there, and now d 1 is there. Then now plus, now it became 3 unpaired electrons. Then this 3 unpaired electrons accounts for 3 oxidation state, because they can lose these 3 electrons. Hence +3 oxidation state is possible. Okay. Now second excited state. Then now only this px was having 2 now only. Then that will also 1 electron will go to the D. Then now everywhere 1 electron will be there. In P, 3 orbitals all are 1, 1, and D, 2 orbitals are there, then they have single, single. Means all 5 are, you can say single electron. Then now 5 unpaired electrons account for +5 oxidation state. Okay, but they can't take 5 electrons. They can't pair by taking extra 5 electrons, because there it is very difficult for them to take the electrons. Okay, due to repulsion, too much repulsion. Okay, but they can remove, because repulsion is there. After losing the electron, they will get relaxation. Now you can see third excited state. Now here means that NS 2 electron was there, 2 electron. Then now what will happen, that actually it will require too much energy to excite. Generally NS will not excite, but here actually that NS electrons are also going to be excited. Then now only 1 electron will remain. Only 1 electron will remain in all, because 1 electron will go to the d orbital. Then in a d orbital 3 electrons are there, all are single. And now in NS 1 is remaining and NP 3 are remaining. Then total how much? Plus 7 I can say this unpaired electrons are there total. That's why +7 is possible. Okay. The higher oxidation state of chlorine, bromine and iodine are recalled mainly when the halogens are in combination with a small and highly electronegative fluorine and oxygen atoms. This higher oxidation state I am talking about. The higher oxidation states of chlorine, bromine and iodine are realized mainly when the halogens are in combination with a small and highly electronegative fluorine and oxygen atom. Example, in interhalogens. In interhalogens means they will react among themselves. Halogen atoms, they will react among themselves. That's why it is called interhalogens. Okay, as for example, fluorine can react with chlorine can react with bromine, like that way. Fluorine can react with any you can say atoms of halogen. Any members of halogen among themselves they can react. That's why it is called interhalogen. Question is asked. Okay, then higher oxidation state occurs only that time. Okay, that higher oxidation state of chlorine, bromine and iodine are realized mainly when the halogen are in combination with the small and highly electronegative fluorine and oxygen atoms. Examples, in interhalogens, oxides and oxoacids, there you will find all the things. First, you will get higher oxidation state in interhalogen. Second, you will get in oxides. And third, in oxoacids. The oxidation state of +4 and +6 occur in oxides and oxoacids of chlorine and bromine. +4 and +6. This you will get in oxoacid and in oxides. Okay, this is a very, very important point. This I told you +4 and +6 occur in the oxides and oxoacids of chlorine and bromine. The fluorine atom has no d orbitals. You know already. The fluorine atom has no d orbitals in its valence shell and therefore cannot expand its octet. Being the most electronegative, it exhibits only -1 oxidation state. All the halogens are highly reactive. They react with metals and non-metals to form halides. The reactivity of the halogens decreases down the group. Okay. Now I am stopping only here, and this I will continue, means chemical properties I will continue in the next class. Thank you.